Assalamu alaikum wa rahmatullahi wa barakatuhu. Friends, welcome back to my channel. In this session, I demonstrated how we can modify a power supply to operate at lower voltage than its rated output. It was 12 volt power supply and I modified it to operate at 8 volt. We calculated the resistors at different parameters and I explained each and every step with detail. In this session, we will see how we can modify SMPS to provide low output. For example, this power supply is designed for 12 volt. I want to take 6 volt, 7 volt, 8 volt. Although there is a setting here, but we need to drive this SMPS less than that voltage. I will recommend never play with any design that is already engineered. But if you want to modify it, we must remember that during this modification process, maybe there is something wrong. This SMPS may dead permanently, or there are some other critical situations. If you want to do it, I will do it here in the video and I will demonstrate it here and I will discuss each and every parameter in detail so that you can copy this method and you can paste to any power supply. If you don't have good experience in electronics, never do this experiment because we will deal with live voltage. In this portion, in live area, we will not touch any component until we are sure that there are no voltage on this capacitor. Even it is removed from power supply, this capacitor will hold charge. In this whole process, I will use series lamp so that if there is any mistake, if there is any abnormality, that will be reflected to this lamp. Locate TL431, that is part of feedback network optocoupler TL431, that is this IC. Locate its pin number 1, that is at left side. This pin, center pin connected to ground, the DC return. This is pin number 3, output pin. It is going to optocoupler. Here is capacitor. We have no concern with this capacitor. This component connected between this positive output terminal, that are these two terminals, and this component connected from here to here, then it is reaching to this 3-pin component. Positive 12 volt output, 10k resistor, this point is reaching to pin number 1 of TL431. This end is connected to ground. Pin 1, pin 2, pin 3. With pin number 1, this component, and it is reaching to this output point before inductor. It is 820 ohms resistor. $10K, 2K, and this is 102, 1K. I will connect directly here, no problem. Now we will measure voltage on these points. DC voltage. Now we will check voltage between ground and pin number 1 of TL431. This is ground, 2.499, 2.5 volt. Voltage between positive and this pin, positive and pin number 1, 8.95, 8.959. Maximum output voltage 11.45. Let's make it 12 volt for best understanding. Minimum 11.45 and maximum 15 volt. 12 volts. check voltage between ground and pin number 1, 2.499, 2.499, that are 2.5 volt. Between positive and pin number 1, 9.534, 9.534, 9.5, 2.5, these are 12 volt. So 12 volt are divided here at this pin. Now we will measure voltage between pin number 1 and 2. 1 and 2, 2.49. Pin number 2 and 3, 10 volt. Here we applied at this point 12 volt. 10 volt are dropped across this component. This is point to be understood. Voltage across optocoupler 1.078. And voltage across this resistor 0.869. 0.869. This time we will verify voltage on VCC pin. That is the basic point for this modification. Pin number 5. This is pin number 7 of UC 3842. Remove power. Discharge this capacitor. Okay. We need to understand some parameters. When we apply 12 volt here in the output, 2.5 volt reference will receive at pin number 1. That time it will allow cathode current for this LED. This time 0.869 volt are dropped across this resistor. It is 820 ohms resistor, and then 11.5. We will do this later on. First we need to increase this voltage. These voltage are pin number 7, this capacitor, VCC pin. This is pin number 7. One ceramic capacitor here for ripple removing, and this VCC capacitor. Positive line is reaching to this component. If we see, here is 10 ohms resistor. That is for VCC adjustment. Then this resistor is connected to this component, this rectifier. And this rectifier is reaching to this point. It is transformer auxiliary winding. Capacitor second end, this one, is jumping here to this side by this jumper. This one. And it is reaching to main capacitor ground. This capacitor ground. That is this point. That means this VCC capacitor one end is grounded. That is this one. And this is connected to resistor diode. We will remove this end. Diode this end. That is connected to transformer. Now I will take magnetic wire, winding wire, enameled wire. I will insert one end of this wire in that point where we removed this rectifier. Basically I am increasing VCC voltage now. If we will not do this and we reduce output, with the same ratio VCC voltage will decrease. If the VCC voltage will decrease, this IC will go in UVLO, under voltage lockout, and this IC will start reboot. First we need to prevent this IC from entering into reboot. Now I will enter this wire in the transformer from one side. Might be this winding is in direction or opposite direction. If it is opposite in direction to the auxiliary winding, that time the VCC voltage will decrease. IC will start fluctuation. That time we need to reverse the winding direction. 3. Until here I have 1, 2, 3, 4, 5, 6. 6 turns. Now I will connect this end to the rectifier open end. Let's measure VCC voltage now. Yes, this time we can see it started fluctuation. That means new winding is opposite in direction. We need to reverse the winding. How we will reverse the winding direction? We will remove this end from the PCB and we will place to the diode, and connected to the diode will go to PCB. We will swap the connections. So this winding will reverse. And connected to PCB will go to this rectifier. The second end to the PCB. Let's check voltage now again. That's nice. The voltage are now 23.33 volt. Before this, the original voltage was 11.5. We added 6 turns and now the voltage are 23 volt. 23.31. That's great. Now we will remove this resistor. And we will verify the value of this resistor. I opened this resistor from one end, 1.953, 2K resistor, and potentiometer is now at 678. 1956 plus 678, 2634. 10K plus 10,000, 12,634. 12 volt divided by 12,634 multiply with 1000, 0.95 milliampere. Let's suppose I want to adjust this power supply at 8 volt. 8 volt divided by 0.95, 8.95, 8.4K resistance total, RT 8.42, 2.5 volt here, 2.5 divided by 0.95, 2.63, the same resistor. We need to decrease the resistor here. 8 minus 2.5, the remaining voltage 5.5, 5.8K. The new resistor value 5.8K. $5K. This time I don't have 5.8K. I will use 1K resistor with this 5K resistor. Now I connected two resistors in series. 6K. I will connect this resistor at place of 10K. Now our expected voltage are 8 volt. 8 divided by 12.6. We will multiply it with this 820 ohms. Our new resistor value is 546 ohms. I need 546. I connected two resistors, 330 and 220, 565 ohms. So it is almost closer value. I will remove this resistor now. Let's apply voltage. Yes, VCC voltage are 14.86 volt. When we installed new winding, the voltage were 23.3, but after decreasing the output, these voltage are also decreased. 14.8, that means we have still headroom to decrease the output. Let's check output. Yes, fantastic. 8.19. Why these voltage are 8.19? We calculated at 8 volt. This is because I installed a slightly high value resistor here, 6K resistor here. Now we can adjust these voltage from here. Now let's see its feedback network. 0.616. 0.616 volt divided by 560 ohms, multiply with 1000 to bring in millivolt. It is 1.1 millivolt. Here were 0.869 volt drop when resistor was 820 ohms. The original resistor 804 ohms. 0.869 divided by 804 multiply with 1000, 1.08. The target LED current for the optocoupler was 1.08 milliampere, and now 0.616 divided by 560 multiply with 1000, it is 1.1. So it is exactly closer to the original current. So this feedback network will work with exactly same CTR as the circuit was working at original components. If you enjoyed this video, give a thumb up. If you have any question, please write in the comments. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.